All right, your assignment for today is the Universal Gravitation eLab, or at least starting it. You have received this document if you're in class. If you're not, you probably want to open up this document at home. And then this is your lab equipment. This is kind of a simulation. Basically, you're Dr. Who reference. You're going out into space, deep space, where there's nothing of any significant mass near you. The only mass around is this mass here and this mass here, and you're going to measure the forces on those masses with these force probes, which I don't know if you recognize them. These are the same force probes you had for your interactions lab a couple weeks ago. So you can see what you can do here. For this lab, you can use a ruler, and you can measure the distance between these two objects. I kind of imagine that you could actually drag that ruler around, but okay. And then you can scooch the objects around. Oh, there you go. That's how you measure there. Notice, by the way, that the 0 is at the center of this object, right? Okay, so we're making our measurements for distance from center to center for the objects. So you can scooch the objects around distance-wise, and then you can read the forces. Okay, so this is one of your force probes. Hopefully you guys understand why it's only giving you one force probe to read and not giving you the other force probe. If you don't understand why, you should probably ask your classmates why that is, and hopefully they'll know too. All right, so that's the force probe. Notice this is 55.9 micronewtons. For you guys who remember unit 2.5 and your metric prefixes, micro is 10 to the negative 6th. So this is 55.9 micronewtons. Make sure you enter the forces in correctly with the right units, because we're going to be measuring forces in newtons, not micronewtons. All right, so you click on that to get out of there, and then you can change the attributes of the different objects. So you can change what it's made out of. You can change its, you can change, make it bigger or smaller. There we go. Okay, and what we're going to be worried about in this particular experiment is masses, right? So you can change the mass of object 1, make it bigger or smaller. You can change the mass of object 2, make it bigger or smaller. You can change the distance between the two objects, and you can measure the force. So those are our 4 variables, right? The distance between the objects, the mass of object 1, the mass of object 2, and the forces. So you're going to be doing 3 experiments. Your 3 experiments are, open up. Don't open it. So glitchy. Okay, fine. Oh, it is open. It's been open for an hour. So, your 3 experiments are gravitational force versus the mass of object 1, gravitational force versus the mass of object 2, and gravitational force versus the distance. So you're going to kind of use these guidelines to design and carry out these experiments. Here on the first page are your predictions. So I want a graph for experiment 1, a graph for experiment 2, a graph for experiment 3, and then describe what you think is going to happen in your hypothesis. Describe the relationship between those 2 variables. What I'm looking for a written description that matches the graph prediction. All right. Okay, so you're going to make graphs probably using Google Sheets, or some of you will use Logger Pro, some of you will use graphical analysis, and that's what you're going to turn in today. If you finish 3 experiments today, I would like you to type into this all of the data for all 3 of your experiments. So you can type, it's me. Oh my God. It's me. I'm going to type, let's say, I don't know, mass 1 went from 1 to 2 to 3 to 4 to 5. It won't, because you can't change it that way. But in mass 2, let's say that was constant at 3 the whole time. Okay, so this is my first experiment. My distance was, I don't know, 3 meters. Probably not. And that was constant the whole time, right? And then my gravitational force was, what did it say there? 55 micronewtons, 55 micronewtons. Micro means 10 to the negative 6. So the way to type that in computer shorthand, E minus 6. This is the 55 micronewtons written in scientific notation, all right? So when you enter in your data, that's what I want you to do. E minus 6. It might say micro, it might say nano, it might say milli. So you need to look at the prefix that's there in front of your force probe and make sure you type in the appropriate power of 10 for your scientific notation in these boxes. Make sense? So then you do your second experiment, maybe these are constant, whatever. And then these masses are, whatever. Okay, so your constants will be the same number through here. So you're going to fill out all of these boxes. Things that were constant in your experiment will be the same number all the way through, and then your independent variable will change, and your dependent variable, the gravitational force, will change. Make sure you pay attention to how these are written in scientific notation. Cool? All right, so hopefully that will let you get a good start on today's homework, today's classwork.